morning. All right, today it is a weekend, so I am going to spend a little bit of time trying to figure out how the file colors works in the summoning. I'm going to demonstrate a little bit what I'm thinking about, and then we'll get to it. But the basic gist here is that they use, for a lot of the animations in the summoning, they use palette swapping. And I haven't totally figured out how to debug that palette swapping, or how to replicate that palette swapping, and today I decided it's time to actually do it. So let's start out. Let's take a look. I've got my dispersing. I've been working on a core dump analyzer. I've got the Python code for this setup. Here, let me move myself over here. But I've also got a KSY file, a Kaitai struct file. And I've got my Ghidra data sets. But the basic thing I'm going to try doing first is I'm going to show you what the palette swap looks like. Then we are going to build out a set of images and then see if we can figure out where the colors come from in the colors file. So the very first thing, I'm letting my DOSBox-X build go because I want to do the latest debug version of that. But here, while that's working, I'll show you what I'm talking about. So this is going to pop up a new window. Let me pop that out, hop it on over here. And we can take a look at the asset browser and the colors. So let's take a look here. Put that here. I'm going to get rid of my tile info file. Import dispersing, ts equals dispersing the summoning. So I've got this asset. Oh, goodness gracious. All right, I'm going to revert back to my, looks like I got a little bit ahead of myself. Let's go ahead and restart run all cells. Yeah, I got a little bit carried away with updating my XOR strings. All right, so we've got this colors file. And this colors file, and here I can show what that looks like. Basically, this is a set of palettes. There are, I guess this should probably be N palettes. And each one has 128. Oh, one moment. All right, I'm back. So each one of these has red, green, blue. Now, if I'm remembering correctly, these are, they only go up to 64, but anyway, the idea is that each one of these is a set of palettes. There are 15 different palettes. Each one has 128 colors. Now, I might be incorrect on that, so we will take a look at that in detail here. But if we look at this, palettes, okay, each one of these is an individual palette with colors associated with it. Oh, hey Rugs, how's it going? Good to see you again. I'm back at the that one project that I'd been experimenting with. This isn't the black holes today. So let's see if we can take a look at each one of these colors. So I'm going to do for color in that. This will be color.r. It's just R. Oh, it's red. All right. Oh, nice. What kind of fields? Yeah, so this maxes out at 63. All right, so let's come up with each one of these pallets. So what we'll do... Oh, all right, fair enough. We have had some crazy weather here the last couple days. Yesterday it was 82 degrees with like 35-mile-an-hour winds with gusts up to like 50. Today it's thunderstorming. So we'll do pallets equals np.zeros. We want this to be, there's 16 pallets, 128 colors in each. So this will be 16. Actually, I'll make this 64 by 128 by 3. No, I'm in central Illinois, actually. Okay, so now what we'll do is here, we'll do for pallet in pallets. Now, there's probably a way to numpyize this. I'm not going to do that, though. We want to replicate this by a factor of 4, so pallets, so for color in palette.colors, palettes, oh, and here this will be palette in, we'll enumerate this, palettes we'll, you know what, I'm just going to do this, we'll fix the aspect ratio instead. Palettes looks like I got reconnected, but I was having some issues with connection. Yeah, it is nice to have something a little bit better than cold. Cold was getting kind of old. Alright, so we've got this now. Here, let's take a look at what this looks like. Import matplotlib pyplot splt. So we will do plt.imshow palettes. That's going to have a funny aspect ratio. Yep. And in fact, note here that it only goes up to 63, so none of these get very bright. 63 goes into 256 4 times, so we multiply by that, and there we go. So this is our full set of palettes. Now I want to point a couple things out. Note here that seems like there actually are multiple different sub-palettes in here. We will take that into account shortly. And the second one is you can actually see here these are progressions of colors inside the palette that are likely related to animations. Alright, so let me go ahead, aspect equals 4. There we go. So that does it a little bit better. And so here we've got this going a little bit better. Let's do aspect equals 8. Oh yeah, gross. Interpolation equals nearest. There we go. So here, this lets us actually see these things a little bit better. Now, I don't know what's going on here. We might have to deal with that later. Perhaps I'm doing something a little bit wrong with the unpacking of the data or something. It's also possible that my interpretation here is backwards, and that really this is that we're supposed to be looking along this edge. But I'm able to get some resources, so I'm not sure that it is completely wrong. Let's take a look now. DOSBox is done building. So let's run it. All right. All right, and now we are going to run this, and then what I'm going to do is I'm going to take multiple screenshots in a row, compare the palettes and identify the pixels where they differ. Come on, where? All right, so let me load up my manual. Okay. Now I think that's actually also palette swap. So one of the neat things about DOSBox X is you can do palette debugging. So now let's compare that here. Do we see anything that looks right? This and that. You see it's shifting this palette segment here. And it does it for each scan line. You can see the changes. Alright, let's go to page 18. We've got that guy, chainmail, feather, and Riker. Now it's not changing the palette swap, or it's not swapping palettes when I move my mouse there. I'm just going to select a character. The fade in and out actually seems to change it. Okay, this is doing some swapping. You can see right there. Huh, that's interesting. Oh my goodness. Oh goodness gracious, I'm having a realization. This is the only palette swapping animation that's happening. Oh, this is really something. Okay. What we're going to do is we're going to take a couple screenshots. Okay, so now I've got a bunch of screenshots. I'm going to put this over here. Let's take a look at these screenshots, because I'm starting to realize that I was making this way more complicated than it is. Capture. Oh, this includes the full debug palette. Okay, or the full debug info. I think there are 4. Yeah. So let me get rid of my duplicates. That's a duplicate. Is that the same as this one? No. Are any of these the same? Really got to focus in on this area. Okay, let's zoom way in over here. Okay. these two are the same. So we've got those two are the same. One, two, three, four. And then it restarts. All right, so we've got those four. And so now we've got this animation and this animation. Okay, so now let's pull up that sprite. And I think it's this. Let's open this in a new tab. Let's zoom way in. Yeah. I think we're seeing these two things cycle. So this is 1, 2, 3, 4 elements indexed in at that point. All right, so let's pull up those sprites, see what we can find. I think I was able to identify that. Let's see, let's go to levels. So this is our wall decor. No. Here we go, wall overlay tiles. So this is one that goes on the right facing walls. Oh yeah, right facing and left facing. All right, so left facing wall. That's what we're seeing there. So now let's debug that. Okay, so ts levels 0 dot level asset dot properties dot. Okay, wall overlay tiles 10. Does that mean that's the offset? Yeah, sprites offset. What's the offset here? Sprite offsets terrain, okay. Sprite offsets dot terrain. So 1012, so ts dot sprites 1012 plus 10. Resources. Okay. Well, that's not right. Let's see, the wall overlay tiles. Sprite offsets dot terrain. So props attribute. Oh, that's wall offsets. Okay, so wall decoration. 1186. There we go. All right, so now each one of these frames is a different element in it. So let's figure out how do we then let's take a look at the underlying data inside that frame. So resources sprites 1196. Let's go back to KSV for this. So this is 1186. Oh, wait, no, 1186 plus 10. So 1196. Let's take a look at our actual asset here. Header size 7, header. Field 1, field 2, field 4, algorithm 3, field 6. And now let's take a look. Maybe one of these colors just gets cycled slightly. So let's take a look at our actual contents. And the contents include each one of the 10 frames. Are there 10 frames? Yes, 10 frames. Okay, so let's figure out what this, let's see, field 1 equals 10, field 2 equals 16. So width over 8, so they should be 16 by 16. Let's go back to this and let's take a look at the rest of the palette here. Does the rest of the palette change at all? No. Okay. So let's get the coordinates here that change in it. For that, I think we'll use PIL. Let me get the rough coordinates here. Okay, so let's load up PIL. Okay, F1 equals, let's see, where are these located? Oh yeah, image dot, is it read? Load, open. Yeah, okay, image open. Seven, so that'll be F2. And now we're gonna have to cut out manually the items in this. We've got 8 and 9 as well. Okay, so let's see, F1, let's see, can I do this? Nope. Can I crop? Left, upper, right, lower. All right, let's do left, upper. It's pretty big. Can I really not get the mouse coordinates? All right, well, all right, let's do crop. It's a tuple. No, that's not it. That's down here. Oh, right, because that's my coordinate system is lower left. All right, well, let's do 50 to 100, from 100 to 600. All right, it's a little bit better. Still way over there. Oh yeah. Left, upper, right, and lower. So left, we're going to want that to be 0 probably. Upper, we'll do 0. The lower, we're going to do, I don't know, 200. And right will be 480. Okay, that clearly didn't work. There we go, getting closer. Let's see, let's drop this down a bit. That's getting closer too. Right, let's make it visibility. Okay. So this should do it. Alright, 2, 3. So let's crop all these. So now we've got, oh, I want to crop out the mouse too. Okay. Let's jump this over to 400. And then right, let's drop that back down, might as well. There we go. So that gives us all of our all of what we're looking at there. Yes, a bunch of these are the tools that I wrote in Python. The image generation is not one that I wrote. Well, so hold on. PIL is not one I wrote. All the asset browsing I did write. What I'm going to do at this point is take that image processing and let's do, we'll do it to buffers. So did I already import NumPy? Yeah, I did. Okay, so np.fromBuffer I1. So what we're going to do now is we're going to take these 4 images. We're going to figure out the differences between them. We're going to figure out where they exist, where those colors exist in the palette. From buffer. I guess maybe I just have to do array. Yeah, because it's not a buffer, but it does respect the array protocol. Yep, there we go. So if I do this for all of them, it should produce the exact same set of values. So if I do A1 not equal to A2, ooh, I'm getting different values? Oh no. Dang. Okay. Well, that's not great. This is not changing exactly the way that I thought it would. It's possible that, well, alright, let's see if we can browse this really quickly. Images equals I1, I2, I3, I4. And this will return just that frame. So let's see, where? Okay, some of these are the same. So there must be a gradient in there. Okay, so let's take a look. Let's go back here, let's see. I think part of it is because we've got these changing as well. Some of them might be animated on different. The torch is probably animated on that, and the fire is animated on that. Or maybe different components of the fire are animated on them differently. So why don't I see if I can reduce this even more. go. Okay, so if we just do the torch, it's just 52. So now what we should be able to do is we should be able to figure out of those 52 pixels, and keep in mind that's 52, that's, why isn't that a multiple of 3? Well, okay, let's do a 1, x is equal 0. So we have this many unique values. Did I do this? Yeah, all right. Okay. So we'll flatten all of these. That should be reshape, not resize. What we'll do is we'll flatten them all out. Okay, now we'll do FA1, x is equal to 0, size. All right, so there are 165 unique colors. What? Seems like a lot, but it's all there. Okay. So all right, so we've got the same number of colors so far on each one. All right, so FA1 not equal to FA2 dot sum 52. Yeah, some of them are probably sharing one of their channels with another one. Oh, you know what? I should probably... Okay, so we want to do not equal along all 3 dimensions. Or we want to make them so that they're not. We want to go back to palette indices somehow. And then look at what the underlying values in the sprite are for those indices. And there's obviously some modding of 4 going on with the number of frames. So let's see, after doing the palettes here, this is probably just wrong, the palette 4. Maybe one of these fields is the number of cycles that it ticks over. up. So what I really need is I need to look at this asset, ts.resources, sprites, 1196, frames, 0. That's it right there. Frame 0 is equal to that. Okay, that's an image. I don't really want that. Let's go back here. Sprites. Okay. And what type is this? It's a dispersing sprite resource. So it's got an IPython display. Here we've got frames, self.frames. Okay, self.im. Let's say torch. Sprites 1196. Torch.im0. Alright, so this is my, what? That's all 0. That's all 254. That doesn't make sense. It doesn't make any sense. How the heck did it? Self.frames append PI image from array palette IM. But that IM is a different shape. So it shouldn't work at all. All these are it's just it only has one value. How the heck is that possible? Huh. It's not even the right shape. This doesn't. Type torch.im and p.ndarray torch.im shape. Okay, so it's got 10 frames. They're each 16 by 16. Oh gosh. Huh. There we go. All right. So this is our torch in its bitmapped format. So if we do plt.im show torch.im, it'll look like a torch. No, that's the skull. There's the torch. And these are our pixels that represent our animation. These values, which are low, and these values, which are high, the low values are the ones that don't change. The high values do change. So let's do color bar. This one's the interesting one. It's there in the middle. Does that actually change? I want to disable interpolation on this, so resample equals nearest. Let's use image dot resampling dot nearest. Okay, so this, right, we've got the brown right there. Let me create a new view for that output. Put it over here. So there's that. This is the one I'm interested in. Does that red ever change? It does. All right, starting to make sense. So these indicate one particular palette that shifts. If we look at our here, this is our torch, and then this is our flame. Like this is right there at the bottom of the flame. This is the top of the flame. Those brown ones. So really what's happening is this palette does change, but only the upper, however many that is. Because that brown is probably right in there. Okay. Okay. This I don't think has anything to do with it. These palettes and whatnot, I don't think they have anything to do with it. It's just cycling the top N components. Let's see if this is 256. Actually, I should be able to figure that out. Probably about 230. p.unique torch.im. So we got a bunch in the 200s, 203, 225 seems to be the very first one. So that's like right here. That's that one. Okay. Now what I'm going to do is I'm going to put this in here. I want to paste. Well, pasting doesn't seem to work. Maybe if I open this in a new window. Save it. Call this torch palette. Something seems to be messing up with that, so. Yeah. Okay, this seems to work. All right, now I'm able to import that. Flying up. Let me get my, where'd it go? Here it is, okay. This is what I want to import. image. And copy image. Okay, so this is our progression. Okay, let's distribute horizontally. First of all, line bottom, distribute horizontally. Okay, now we can see all these things. All right. So what we're really seeing here is we're seeing the palette switching seems to be keyed to particular palette values. Or rather, subsets of the palette get reloaded. So let's take a look. This let's see. Which thing? So which animation best corresponds to it? I think it's this one. But we can take a look here. So let's these change, and really what we want to look for is we want to look for the progression left and right. And it looks like that's maps pretty well here. But note that the actual colors vary. And it's not just motion left to right. Or is it? The purple seems to vary. Maybe this is wrong. But no, I think it is actually just shifting them left to right. This might be a little different, but these do look like they're just shifting left to right. See here, this one gets moved all the way over there, yeah. So this is probably just like the last four have some freedom and flexibility. Okay, so let's go back here. If we look at the unique values here, this is 249, 250, 251, 254. 254 is not part of it. That's empty. But we're clearly seeing this and this are in the main palette, and then the last, I guess, I don't know, 24 or so, or 32 maybe, values are switched. So let's take a look in Ghidra, where it does the color palette switching. Okay. This is one place that it reads the palette. Here's another palette manipulation. Copy RGB, size 405, 256. No, that's an offset. And then this updates. So does this happen with some... that's just the endgame sequence, alright. Read partial palette. Number of colors, 256, that's an entire palette. um, Looks like I dropped out for a second there, but it says that I'm back. Yeah, I guess I'm back. I'm not going to be on for too much longer, though. I've got to take care of some other stuff. But I think this is the key realization here, is that it actually, underneath everything else, shifts the palette with some specific time. So it copies these triplets. This is actually where I think the main stuff happens. It copies triplets. So this is the destination. Oh no, that's the start. It probably copies that many triplets. So 4, 8. Hold on, wait. Copy buffer, local 6, source. Okay, so if 1 is less than param4. Okay, so param4 is greater than 1. Alright, so that just checks if it's doing the right number. Param3 times 3. So that's one set of offsets. That's another set of offsets. That's the set of full palettes. So let's change this one to offset 1, offset 2, param4, num triplets, local 6. Why is it copying buffers 3 times? So it copies from the source, copies 3, and it copies source, or copies the source in a local 6, copies start plus the offsets into source, then it copies the next triplet into local 6. Oh, I see. Yeah, this is the animation. So this probably gets called on a timer. Yeah, post int 60 after it checks. So let's change this name. Animate palette. This is where all of the animation occurs. So what it's doing is it's copying a set of 4 triplets. So 1, 2, 3, 4, 5, 6, 7. So 21 values? That doesn't sound right. 256. No, that sounds wrong. But I guess maybe it's not. But it starts at 224. Okay, so it starts at 224. So everything above 224 is in the animated range. Everything above 224 is in the animated range inside one of these sprites. And so it updates these palette triplets based on that. and then it copies the current palette, size 252. All right. And then it updates the draw. Okay, so I guess this answers everything at this point. Everything at 224 and above is part of the animation. Oh, and you know what I bet it is this does an offset. So 4 triplets, 3, 4, 5, 6, 7, or maybe, yeah. So it should go up to 245. Yeah. So if I want to animate this, I can have the palette animation here. And what it's doing is it's doing a clever little copy here. I'm not sure this is actually copying the triplets. I think it might be rotating them as well, which is why I think there are 4 here. So this is a hard-coded number of 4 frames. So it's not just copying triplets. Yes, it's copying number of triplets. So this copies 4 triplets, 4 triplets, 4 triplets, 4 triplets, 4 triplets. And it's rotating them because there are 4 total frames, which is where this comes from. It logically ends it with 3, which truncates it to be 4 frames. So if I look at this in sequence, it should only ever get up to 3. So the start here is 224. And it goes up here to 236. And then 240. No. Yeah. All right, so that's where all this happens. It happens above 250 or 244, 224. So all of the palette IDs above 224, including 225, which is this one right here, are the animated frames. And they get drawn from basically modding it and then choosing the sub palette from within that. Offset within the subs palette by a mod of 3, basically. All right, so I think I can implement that. Now, it'll take me a little while to do that, though. But I think I can, and I think I should. I'm going to change this to be update palette frame. And this is probably rotate triplets. But I'll deal with that later. Okay. All right, well, I got some other stuff to do this Saturday. I'm going to go back to talking here. Just as a reminder, you can always call your congressional representatives by calling the main switchboard during business hours during the week. Be sure if you're in the U.S., you call only if you're in the U.S., and make sure that you talk to your representatives of whom you are a constituent. You can just share with them whatever you like. Okay, so thanks for joining me. It's good to talk to you, Rugs, and have a good rest of the weekend.